Hi guys, let's talk about physical applications that we come across and talk to. So, when you think about physical applications, you should think about some things in physics that you come across. So let's have a look at a couple of formulas that we will use. These you could write down and keep it in your cheat sheet or somewhere so that you could use them whenever you need to. You know. So the first one is the work formula. So the work is equal to force times distance. And we use this formula when the force is constant. Okay. Another formula is force equals mass acceleration divided by weight. And another formula is work equals mgd. Okay, so do you know these two work formulas? So force is actually equal to mass times acceleration. Okay, that's why we kind of plug that in over here. Okay, that force equals mass times acceleration, and acceleration sometimes is, you could just refer to that as g, which is that acceleration due to gravity. Okay, but the units are gonna be in joule for work, kg or kg meters per meter square over second square. Okay, and work equals, remember, work equal, in another formula, when we're trying to actually, you will come across soon. You just keep this in your handbook for now. PGVD dx. So P density, acceleration due to gravity, V is for volume, D is for the depth. Okay. And one more formula is f of x. F of x, by that I mean f, the force. Okay. The force. So we're gonna find the integral from a to b of f of x dx. So it's not going to be the force. It's not going to be the force. It's going to be the function. Okay. So when do we use this formula? We use this formula when the force is variable. Variable means it's not a constant. It keeps changing. It could change at some point, or at any point. Okay. So that's for variable force. Variable force, we use this formula. Constant force, we use this formula. Okay, let's have a look at a couple of problems using this. Okay, so for our first problem, we've been given that the density function is equal to 2 minus x over 2. Okay, so, and they ask us to find the mass. Find the mass, okay? So how do we do this? So we know that the mass is equal to the density, the integral of the density. Okay, integral of density. I think we mentioned this, the formula. Let's add that formula also over here. So mass equals integral from a to b of density dx, density function dx. Okay, if you get this question in your test and exam, it should be an easy one. Okay, I'll show you how. Okay, so and they've given us the points from 0 to 2. Okay, from 0 to 2. So all we do is just plug it in from 0 to 2. You know the density function they gave us is 2 minus x over 2 dx. Okay, now if we go on to find the integral of this from 0 to 2, integral of 1 second. So the integral of 2 is just going to be 2x. Minus x over 2 is going to be minus x squared over 4 from 0 to 2. Okay? We plug in the 2, it's going to give us 4. Minus 2 squared over 4, that's going to give us 4 over 4 minus 0 plus 0. Okay? So that's going to equal 16 minus 4 is 12. We're going to multiply denominator and numerator by 4, so it's going to be 16 minus 4 over 4, and that's going to give us 3 kgs. Remember, the units are important here because we are talking about mass. Okay, So let's have a look at another problem. Okay, where we're given that the mass is 5 kg and the object is lifted 2 meters off the ground. Okay, so when we're told to find the work, now we could use a formula that we came across. Work equals mgd. So what do? We plug it in. 5 for the mass. Remember, the acceleration to the gravity is 9.8 meters per second square. You could just put you don't need the units for now. And the depth is 2. Okay, I generally don't like to put the units when I'm solving maths, right? Physics, of course, I would want the units in the question when I'm trying to solve. But since I know it's gonna be in joules, work is in joules, I don't want to put it over here. I just like to play with the numbers and not have the units taking up space. So 98 joules, that's gonna equal 98 joules. Ready. So that was using one of our work formulas. Now let's have a look at another one of problems. So a 30 lb box lifted how many feet? 4 feet. Okay, and they've asked us to find the work. Now this lbs, we gotta remember that lbs accounts for the gravity. Accounts for gravity, acceleration due to gravity. So we could directly plug it in into the work equals mass times mgd, mass times depth. Why? Remember the formula was mgd, but now the lbs represents mg. So we could just plug in 30 times 4, and that's going to give us 120 feet per lb. And this is what is going to be our work. Okay, moving on. Let's solve a problem where f of x is equal to x squared minus 4x plus 7. We've been told to find the work, okay, from 1 meter to 4 meters. Okay, now remember, it's going to be variable over here, the force. It's not going to be constant. Okay, so we use our variable force formula. So it's going to be from 1 to 4. Okay, 1 to 4 of f of x dx. Now that's going to be equal to 1 to 4 x squared minus 4x plus 7 dx. That's going to be equal to, if we try to go on solving, x cubed over 3 minus 4x squared over 2 plus 7x, solving the integral from 1 to 4. Okay, and now that's going to be equal to 64 over 3 minus 64 over 2, plugging in the upper bounds and the lower bounds, minus 1/3 minus 4/2 plus 7. Now we could go on solving. So, and then as we go on, we're going to come to a final answer of 21 minus 9. And that's going to give us 12 joules. Ready. So that was one with the variable force. Now let's talk about springs. Okay, springs. So the f of x function for springs, right? The force function is going to be kx. Okay, now let's have a look at a problem to understand how we could get some problems. So let's say the mass is 50 lbs. To the weight, we could say the weight. I feel like weight is a better term. We've been giving it equals to 50 lbs. Okay, and the spring is moved. It's moved 5 inches. Okay, and we've been asked to find the work. Okay, work required to stretch the from rest to 10 inches. Okay, so initially the spring is at 5 inches. Okay, so now we gotta, the first step, we gotta find out the k in our f of x function. So what we do, we equal k of x to mg. Okay, since that's gonna be the weight. So k we know is initially stretched to 5. Okay, and mg is gonna just be our weight. Okay, which became TLB. Remember that counts for gravity. Okay, and then k divided 5 both sides, it's just gonna be 10. Okay, k equals 10. Now let's find the work. Work is going to be equal to the integral from 0 to 10 a of x, kx dx. Now we found out what kx was, so that's going to be 10 and x dx. Okay, so from 0 to 10, so now if we find the integral, it's going to be 10x squared over 2 from 0 to 10. Again, solving that, 5 minus 0 squared, that's going to give us 500 inches per lb. Inches lb. That's lb. Remember, work, the SI unit of work is joules, but then you could represent it in different units depending upon the question. Here we've given it in inches and lbs. Okay,